Have you ever wondered how the internet knows where to send your emails or load your favorite websites? It's all thanks to DNS records, the unsung heroes of the internet. DNS, or the Domain Name System, is a foundational technology of the internet that translates human-readable domain names into machine-readable IP addresses. DNS acts as the internet's phone book, enabling seamless interaction between humans and the underlying infrastructure of the web. Without DNS, using the internet as we know it would be far more challenging. DNS records, also known as zone files, have different types and formats of data entries stored in the domain name system that define how requests for a domain or subdomain should be handled. Each record type serves a specific purpose, such as directing traffic, managing email, or verifying domain ownership. These records enable DNS to perform its primary function, translating domain names into IP addresses and providing other essential information about domains. DNS record types are important because they help with routing traffic, email handling, security, and service configuration. The first type is an A record. A record stands for address. This type maps a domain name to an IPv4 address. This type of record only supports IP version 4 addresses. The main use of this record is for IP address lookup. Next, we have quad A record. This is similar to an A record, but maps a domain to an IP version 6 address. IP version 6 offers more addresses than IP version 4. This type of record supports modern networks utilizing IP version 6. Following that is the CNAME or canonical name record. This type points a domain or subdomain to another domain name. It acts like a nickname or alias for a domain. Instead of pointing directly to an IP address, like an A record, or creating two A records, it points one domain name to another domain name. Imagine you have the main website and its subdomain. Instead of managing a separate IP address for the subdomain, you can create a CNAME record. This helps with consistency, ease of management, and load balancing because it helps distribute traffic by pointing to dynamic services like content delivery networks. Afterward, we have the MX or mail exchange record. This specifies the mail server responsible for receiving emails for a domain. This means it directs emails to your domain mail server. These records work with an email server to enable the setup of personalized email accounts. Additionally, we have text records. This type stores arbitrary text for various uses, like domain ownership verification and security. These records are frequently used in various email authentication protocols. Moving on, we have NS or name server record. This type specifies the authoritative DNS servers for a domain. It ensures queries for a domain are directed to the correct DNS servers, meaning it directs internet applications, such as web browsers, to the location where they can retrieve the IP address for a domain name. Similarly, we have CAA or Certification Authority Authorization Record. This specifies which certificate authorities are allowed to issue certificates like SSL/TLS for a domain. A certificate authority is an organization that verifies website identities and links them to cryptographic keys by issuing digital certificates. This enhances security by reducing unauthorized certificate issuance. Another important type is the PTR or pointer record. This is the opposite of an A record. It resolves an IP address to a domain name, essentially a reverse DNS lookup. Instead of linking a domain name to an IP address, PTR records associate an IP address with a domain name. When a DNS query starts with an IP address, the PTR record identifies the corresponding hostname. This is used in email server configurations for spam prevention. Next is the SOA or Start of Authority record. This provides essential information about the domain, including the primary name server, admin email, and DNS zone properties like refresh rate. Then, We have SRV or service records. This type is used to specify the location of a particular service within a domain. It provides information about which server offers a specific service, as well as the port number and priority for accessing that service. When an application or client queries the DNS for an SRV record, the DNS responds with the details of the server, including the port and priority. The client then connects to the specified server to use the service. Common uses of SRV records include voice over IP, instant messaging, and Microsoft services. Furthermore, we have DNAME or delegation name record. This is a similar record to the CNAME record, but applies to all subdomains. Essentially, it redirects an entire domain subtree to another domain. Additionally, there is the DNS key record. This type stores public keys used in DNS security extensions to verify the authenticity of DNS responses. This ensures integrity and prevents spoofing. Finally, we have NAPTR or Naming Authority Pointer record. This record provides dynamic DNS capabilities, often used in telephony and internet services. It allows you to set dynamic rules for how your website processes requests. These were the most known DNS records that you would find in a DNS server database. If you found this helpful, give this video a thumbs up and subscribe for more cybersecurity insights. Remember to use a password manager. I will see you in the next one.